I'm Mike O'Neill, and I'm a data nerd who uses Azure Data Explorer, or Kusto, every day to glean insights into Azure's developer and code-to-customer operations. A data engineer that I work with recently asked me what he should do to deliver high-quality data. I didn't have an easy answer. Data quality isn't something I've classified in any way, it's just something I've learned how to do through trial and many errors. I discussed it with my boss, and she tossed down the metaphorical gauntlet. Michael, list out the different data quality tests that you think are necessary. My first reaction was that the most important thing for exceptional data quality is to have as many people look at the data as possible. That's a bit of a dodge, I'll admit. Linus's law really does apply here. Given enough eyeballs, all bugs are shallow, but there are never enough eyeballs. There are a lot of things to look for, and I'll create a video for each one. That said, if you've been in the data engineering space for a while, you should probably skip to the next video right now. Identifying potential dimensions is one of my top tasks when I look at a completely new data source. And for this video, I'm just looking at simple dimensions with a handful of values, maybe a few hundred at the extreme. I'm not looking at complex dimensions such as product catalogs, which could have tens of thousands of values. Anyway, all I do is examine every column that might be a dimension of some sort. Generally, I ignore date times and real numbers, but short strings and bytes are good candidates, and I'll look at every single one. What I do is I aggregate them, getting a count of rows for each potential value. Now, at this point, it becomes art rather than science, but a histogram can help push the scales a bit more into the science side. Take a look at this histogram. We're looking at how different teams at Microsoft name Azure's data center region. I get 168 values from this query, but I know that Azure has 56 regions. It's just that different service teams are naming the regions differently. Now, look at the shape of that data. While I have a long tail of values, the bulk of my data looks like it falls within a small set. In fact, just 23 out of 168 values account for 80% of the rows in my dataset. To me, that feels like a decent candidate for a dimension. In contrast, look at deployment actions. These values represent all the complexity of delivering new features to Azure. And I'm not using the word complexity lightly. There are over 9,000 different actions here. I can't even generate a histogram in Kusto. It's got a max of 5,000 values. Excel doesn't have that 5K limitation, but even then, you can't even see the histogram there. The long tail of values is so long, it's basically meaningless. This is not a good candidate for a simple dimension. Of course, this is art, not science. Azure Regions feels like a good candidate for a simple dimension, but deployment actions doesn't. Still, with 168 different strings rolling up to 56 regions, I also have to make a call about how to handle that. Short term, it's easy to manually go through the list and normalize those values down to 56 regions. For example, Japan East, JPE, and East JP are clearly all the same thing. That solves my problem in the short term. But what do I do if a team decides to add a new value, such as EJP or Japan E? Again, we come to art. I really only have two choices about how to handle this long term. My first option is to create a job that monitors values in this dimension and alerts me whenever a new value appears so I can normalize it. My second option is to go to the team that owns this tool and insist that their users not have the choice to enter in whatever value they want. The second option, in this particular case, is the right choice, but it's also the most difficult choice. As of March 2020, we have 56 data centers, and there's no legitimate reason for one service team to have a different set of characters represent the Japan East region than all the other Azure service teams. But that means getting another team to prioritize work that I think matters. To put it another way, there's a moral hazard for me. If I go about cleansing that data just once, which is actually what I've done in this case, the team owning that telemetry won't have to, and I'll keep having to clean it again and again and again. That said, there's not always a moral hazard in maintaining a dimension. Setting up an alert to manually handle the new value may be the right choice. For example, I was once responsible for providing data to surface marketers, and every year, 2 or 3 months before Black Friday, I would see a brand new surface model name pop up in Windows telemetry. Now, I wasn't supposed to know about that new device until October, but I considered it as part of my job to make sure that the data engineers, analysts, marketers, and data scientists that use the data my team produce didn't know about those new surface models via our data. We made the investment to monitor for new surface model names, and when we found them, not only did we alert the people who were in the know, But we made sure those new model names didn't appear in our data until it was time to execute marketing campaigns promoting them.